All right, guys, a few more sections to go. This is 2.5, 2 questions from here. And there's only 2 types of questions. Solve either the polynomial inequality or the rational inequality. It's possible you see one of each of these questions. So make sure you know how to do both. Start with number 11, polynomial inequality. The first thing you want to do for a question like this is just move everything to the left and have 0 on the right. So this is going to turn into x cubed. I've got a minus 4x squared, a minus 2x squared on the other side. To move this 2x squared to the left side, I'm going to add it, right? So the opposite. So it's going to be minus 4x squared plus 2x squared, which gives me a minus 2x squared. Okay, next is the minus 9x. I've got a plus 2x on the right. I'm going to subtract that 2x from both sides. So I end up with a minus 11x. And then a 13 minus a 1 is a minus 12. I'm sorry, plus 12, I mean. And all of this should be greater than or equal to 0. So here's my rewritten expression, inequality, I mean, with 0 on one side. And the next thing I want to do is just basically factor. And as I factor, what I'm going to check is, first of all, what are possible rational roots? And try to reduce it by using my synthetic division here. So possible rational roots. I know the numerator, the p should divide 12. So I'm going to get, and then the q should divide 1. So it's going to just be all whole numbers. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. These are all factors of 12. Plus or minus 6, plus or minus 12 itself. Yeah, so those are the different possibilities for rational roots. Nice thing is they're all whole numbers. And let's go ahead and just check one. I'm going to just go by inspection real quick. If I put in a 1, I think there's a good chance it works. Let's try 1. Here's the coefficients. -1, -2, -11, positive 12. Run my synthetic division algorithm. 1 comes down. 1 times 1 is 1. Plus -2 is -1. Times 1 is -1. Plus -11 is -12. Times 1 is -12. Plus 12 is 0. So that worked. First try. That's nice. This is x squared minus x minus 12. And then from here, I can just go ahead and jump straight to the quadratic equation, right? So I'm going to do x is equal to now negative b, which would be -1. So actually back to positive 1. Plus or minus the square root of b squared, which is 1, minus 4ac, which is -12. All over 2a, which is 2 times 1. And that gives me x equal to 1 plus or minus, this is 4 times -12, -4 times -12 is positive 48, plus 1 is 49, which is nice because that's a nice perfectly squared number. All over 2. And then the square root of 49 is just 7, so I've got x equal to 1 plus or minus 7 over 2. If I take the minus, that's 1 minus 7 is -6 divided by 2. -6 divided by 2 is -3. And if I take the plus, that's 1 plus 7, that's 8. 8 divided by 2 is 4. So notice that matches up with possibilities that I listed earlier, -3 and 4. Okay, so that's good. I've got the roots. And now that I have the roots, or the zeros, I can kind of just plot out where these things are going to be positive or negative. Where is this polynomial on the left side of my inequality going to be positive or negative? And that's what I care about, positive or negative, because I'm comparing it to 0, right? So I'm going to start with the roots. I know I've got 1. I've got -3, which would be to the left of that, and positive 4. And between those spots, I'm going to check test points. So I know if I'm above 0 or below 0. So let's go at -4. What's between -3 and 1? Well, 0 is over there. And what's bigger than 1 but less than 4? Well, 2 is. And what's bigger than 4? 5. Okay, so those are the things I'm going to check. And what am I going to check that with? I'm going to check that with my original expression over here. Okay, and I'm not going to totally solve. I'm just going to do enough to tell whether it's positive or negative. So let's start with -4. If I plug in -4, this is -4 to the third power, and that's really going to take over everything. If I pick a big enough number, like I could go all the way up here to -100, right? Then I've had -100 to the cubed, and then these guys become negligible. So without actually solving, I know that this over here is going to be negative to the left of -3. And similarly, if I go far to the right, if I pick like 100 and I cube that, these guys are going to become negligible. So if I pick 5 or something even bigger than 5, I know it's going to end up eventually positive. Okay, so that takes care of this section where I'm negative and the far right section where I'm positive. Next section to check would be the 0. What happens if I put in 0? Well, this guy's 0, this guy's 0, this guy's 0, leaving me with just 12. So that means this guy is going to be positive. Okay, the other thing I know is that all of these roots, all of these zeros are just, they're single roots, right? Their multiplicity is 1. So if I was to kind of sketch things out here, I know I'm negative, here positive. It's going to pass through each of these roots like this, right? So that means without even actually plugging in the 2, I know that in this region I should be negative. You could even just go ahead and sketch the graph to find that out. But I could also plug in 2 if you want to be extra sure. 2 to the third would be 8, right? Minus 2 times 2 squared, which would be minus 2 times 4. So those cancel each other out. And then I have minus 11 times 2 would be minus 22 plus 12 is minus 10 overall. So indeed it is negative, right? That's just a double check. Okay, so now looking at my sign chart here, which spots am I bigger than 0? Because I wanted to know when I'm bigger than or equal to 0, right? And what I'm going to do now is just highlight those. Bigger than or equal to 0 would be this region here and this region here. So that's where I'm bigger than 0. Yeah? Between -3 and 1 and between 4 and onwards. From 4 and onwards. So now I'm ready to write my solution, my answer. From bigger than, now this includes the equal sign on the bottom, so I'm going to have hard brackets here from -3 to +1, and then also union that with 4 onwards to infinity, open bracket with the infinity. So there's my solution right there. Okay, sweet. Oh, I have a feeling I'm going to cross into, oh no, that worked. Look, that worked. Okay, that was 11. Now on to question 12. Yeah, 11 was a pretty straightforward type of inequality type of question. Now for this rational inequality question. And you know, when you're dealing with rational inequality questions, kind of the approach is pretty similar. It's kind of similar to how you go about graphing first, right? You kind of want to know what's happening with the graph and then look at where is it bigger or less than 0. In this case, this is not a 0. So to make it into a 0, I'm going to change this to have common denominator with this guy down here, and then move it all to that side, simplify, and then so on and so on. So I'll show you what I mean here. This is number 12. First step, I'm just going to move everything to one side of my inequality. So that I got a 0 on this side, right? Subtract 3 on both sides. This 3 got canceled. I got the 3 minus 3 on that side. Okay, next, to make it into one single rational expression, I'm going to transform this -3 to have a common denominator. So what, here, let's do a new line actually. So what's the common denominator? Common denominator would just be x minus 3. 3x minus 3 on the top. Here, all I'm doing here is multiplying by 1 really, right? I have 3 on the top times x minus 3 and x minus 3 on the bottom. I multiplied by x minus 3 over x minus 3, which is a clever way of multiplying by 1. Okay, and then the next step, what I'm going to do, just combine these fractions here. So this is 4x minus 9. Here, minus, let's distribute this 3. So minus 3x, and then minus a negative. Actually, you know what you should do, guys? Actually, let me step back for a second. What you should do is keep this minus separate and just do the foiling first, because that helps you to keep things straight. So 3 times x is 3x. Put this whole thing in parentheses. 3 times -3 is minus 9. Yeah, like this. This is all over x minus 3. Less than or equal to 0. Less than 0, sorry, less than 0. Not less than or equal to. And then from here, combine things, right? So this is going to be 4x minus 9. This is a minus 3x. Sorry, minus 3x. And then this minus gets distributed, so it's minus -9, which is plus 9. I know I'm doing this in painstaking, slow detail. That's just so I don't lose anybody along the way, if you're watching this. I've got 4x minus 3x. That's going to be 1x. Yeah, I just took these two guys. Next, I have minus 9 plus 9, which is 0. So, this is nice. It's just x over x minus 3 is less than 0. Makes it easy. Now, things to watch out for when I have an asymptote right here at x equal to 3, or when I have a 0 right here at x equal to 0. And those are the only two places of concern. So I'm going to check my number line. Those are the only spots where I could possibly change from being below or above 0, right? So at positive 3, because that's the vertical asymptote, and over here at 0. And the other spots, I'm just going to check test points somewhere in between. So to the left of 0, let's just pick -1. In between 0 and 3, how about 1? And to the right of 3, how about 4? Yeah, the obvious choices. Let's check them one by one. If I put -1 here, that's negative up top. If I put -1 down here, -1 minus 3 is negative down bottom. So I've got negative over negative, which overall is a positive. Okay, now I'm going to check positive 1. If I plug in positive 1, this is going to be positive up top. 1 minus 3 is going to be negative down bottom. So positive over negative is negative overall. Okay, and then lastly is the 4. If I plug in 4 up top, that's positive. 4 minus 3 down here, that's also positive. So positive over positive is positive. Now, I don't need to worry about including 0 or 3 because I have strict inequality here. But even if it was less than or equal to, you'd still got to be, or if it was, you have to be more careful because notice that 3 is not a solution anyway, since that's an undefined point, right? You'd be dividing by 0 there. Whereas 0 would actually be included if this had a less than or equal to symbol. Okay, but we have a less than symbol. That makes it easier. We just want to know where we're strictly less than. So that's going to be right here in this middle region, right? Between 0 and 3, but not including 0 and not including 3. Which makes our answer the following. Answer from 0 to 3. Between 0 and 3, those are all the spots where my graph would be less than 0. Okay, now just to, this is kind of a follow-up to that. This is not something that you have to include if it doesn't ask for it, but let's just make sure that we know how to visualize this, get a quick sketch of the graph as well, because that is something for sure you're going to need to know how to do at some point. Even if this particular question is not asking for it, this is good practice. So notice I have an asymptote at x equal to 3. 1, 2, 3. So let's sketch that asymptote here. And in this case, x over x minus 3, they're same power, and the coefficients for both of those are 1, which means I have a horizontal asymptote at 1. Yeah. Okay, my line was crooked, but just imagine that's a horizontal line at 1. Okay, and then I know positive. Okay, I know my 0. Yeah, I know I have a 0 at where was it? At 0. 0. So right here, yeah. That's where it crosses. And I know it's positive to the left. So then that guy's going to approach that horizontal asymptote like this, right? And then it goes negative as I approach that first vertical asymptote. So it's going to go like this. Okay, after that it's positive, which puts me in this upper region here. Approaching the vertical asymptote and then approaching the horizontal asymptote. So this is a sketch of my graph. And you know what, thinking about it, no, never mind. Forget what I was going to say. But yeah, that's the general picture. And it matches what our solution is, right? Where's my solution less than 0? Where's the graph less than 0? Exactly where I said, between 0 and 3, but not including 0 and not including 3. Okay, that's it, guys.